So yeah, this is an introduction to heat pumps. I'm happy to take your questions, and I'm going to go quickly so that we can cover a lot of materials. Um, as um, as you know, we're trying to do a very big thing of changing how every home and business is heated and cooled in the state by 2050. Let's put our shoulder to the wheel. We're going to do basics, what they are, how do they work, costs and incentives, design considerations, and then we'll take questions. So first, about Green Energy Consumers Alliance, we are a consumers group. We've been around for a long time, since 1982. We're doing this big transition of heating without fossil fuel combustion. We are helping energy consumers to find trusted vendors and sound advice. We are trying to move the heat pump industry as a whole by educating consumers. A lot of times you'll call an HVAC contractor and they'll tell you, you can't get there from here, but you really can. And we're trying to push the industry in that way. And we have great resources on our website. So what is a heat pump? It's the same technology as an air conditioner or as a refrigerator, only those things only work one direction, and a heat pump works in both directions, pulling heat into your house or pulling heat out of your house. How does it do this? It's like a water pump, in that a water pump is not creating water. It's just moving water from one place to another. A heat pump does not create heat. It captures heat from one place and moves it to another place. And it's extremely efficient that way, because it doesn't have to blow anything up and then have noxious gases that are a byproduct that don't lead to heating your home. It's really remarkable. 300% efficient, 400% efficient, meaning you put in 1 unit of energy and you get 4 units of heating or cooling back. So they're very efficient to cold temperatures now. Do not let any HVAC contractor tell you you can't get there from here. You can't heat your home with a heat pump. You need to have fossil fuel backup. That's an old story. It was true at one time. And certainly if you put in an air conditioner that's designed for Georgia, it's not going to work in New England adequately. You need one that's sized correctly, that's specified correctly, and that produces enough heat for us. But you can get there. They come in all sorts of forms. Ducted, so if you have ductwork already in your house, it can utilize your ductwork. Also ductless, so if you don't have ductwork, you can have a heat pump. You can have a whole home heat pump, or you can have a partial home heat pump. You can have an air source heat pump or a ground source heat pump. That means the heat would be taken from the air or it'd be taken from the ground. Mostly we're going to be talking about air source heat pumps tonight, but I will touch on the, and mostly I'll be talking about ductless, but I'll talk about the others as well as I can. What does the indoor unit look like when you get a heat pump system? There are 3 types. We call them the indoor unit, we call them the head, or possibly the air handler. The first most common type is the wall hung unit. That's the rectangle that's fairly high up on the wall. That's the easiest to install, and it blows air most easily throughout your room because there's no furniture blocking it. There's a floor mounted unit as well, and that sits low on the floor just like a radiator would. And that's great, particularly on a first floor, because the refrigerant line can actually come through your basement, which is handy. There is also the option of ceiling cassettes, but obviously sticking something up in your ceiling is going to get tricky depending on your joists in the ceiling, etc. So that's the most costly option. It can work well on a second floor where there's an attic above that a technician could work in. What does the outdoor condenser look like? Oh, interesting. So you're, I think, now moving the slides for that screen. I'm not. Something changed. I didn't change it. Anyway, what does the outdoor unit look like? Looks like a large suitcase, really large suitcase. You've seen them probably. It's not the square column that's the common central AC. It's more of a suitcase rectangle. You need to have airflow because it's sucking air in and pushing air out. So you can't have it right up against a wall. Say you've got a retaining wall or something, it can't be right up against that. It has to be raised up so that snow and ice can melt off of it or can fall off of it. Because if it gets encased with ice, you no longer have airflow. And there is a refrigerant line that runs from the outside up the side of your house or along the side of your house into where the indoor air handler will be. Why do we care about heat pumps at all? It's because of the greenhouse gases and because of climate change. The state has set goals to get rid of fossil fuels for heating. Heat pumps are the most cost efficient, the most energy efficient option to replace all those fossil fuel systems. And the grid already produces much cleaner heat through a heat pump than any of the other options. And when the grid becomes 100% clean electricity, which it will be completely by 2050, and you can already opt into many 100% green options. When you're drawing 100% clean electricity, you have no fossil fuel, you have no greenhouse gas emissions from your heating source. So that's why there's a ton of money from the state and the federal government, and sometimes from your municipalities to install heat pumps. How much do these cost? We're going to break down the cost into two sections. What is installation cost? What's your upfront cost? And then what's your operating cost or your ongoing expenses? First, the installation cost. Very rough ballpark. You can think of a single-headed ductless system. Say you're going to put one in your great room in the ballpark of $6,000 to $10,000. These are very ballpark numbers. Everybody's house is different. Depends on how big that square footage is that you're trying to heat with that single head. Now, a centrally ducted system could cost anywhere between $15,000 and $25,000, even more, again, if you're talking large cathedral ceilings, a house that's poorly insulated, a large house with many bedrooms might be more expensive. You could think of the cost as roughly comparable to if you're going to install or replace both a fossil fuel heating system and a central air system. And that makes sense because it provides both of those services with one piece of equipment. An auxiliary cost that many people face is upgrading your electrical service. There may be ways around this for your particular home, but generally it's recommended a 200 amp service if you're going to run a heat pump. There are a number of ways to finance this. Sometimes the company itself will offer financing. There's the Mass Save Heat Loan, which is 0% interest, up to $50,000 if you're installing a heat pump. There's also a new low interest loan for moderate income households through the Mass Community Climate Bank of up to $100,000. And they define moderate income very broadly to include up to 165% of state median income. So almost $200,000. Incentives vary by household size, by household income, and by zip code. And I'm going to give an example of a two-person house in Plymouth, Massachusetts. If that household is low income, meaning that their household income is less than $58,688, the local CAP agency, South Shore Community Action Council, would completely cover the cost of installing the heat pump. Now, you are very lucky to be living in Plymouth because in Plymouth, there is also a special moderate income incentive that will completely cover the cost of installing your heat pump. And that is for a two-person household in Plymouth earning between that $58,688 up to $104,200. So that's the definition of moderate income for the purposes of this, what's called an enhanced incentive. This is a special pilot project. It is just for Plymouth, Brockton, and Springfield. And we have a special guest tonight, Jenny Sensorin, who is sitting here in the front row, who will come up at the end to answer any questions that people have about that enhanced incentive. If you are outside of those communities, the moderate income levels are the same, but the incentive is reduced to 16,000 for your heat pump installation, for your whole home heat pump installation. And if your income is greater than 1,400, 200, $104,200, then you would still qualify for the Mass Save incentive, a grant of $10,000, sorry, per apartment or home. Meaning, if you own a two-family, you could get 10,000 for your home and 10,000 for the apartment that you're renting out. So there are great incentives, and that's just the state incentives. The federal incentives are on top of that. Let me first tell you a little bit more about that whole home rebate from Mass Save for the above moderate income level, the $10,000. That is, if you are completely replacing your fossil fuel heating, the fossil fuel system would need to be disconnected from the thermostat so that you couldn't suddenly turn it on. It is $10,000 per home, regardless, home or apartment, regardless of the system size. So if you need a small heat pump, that $10,000 could be, 90% of your cost, or, 75% of your cost. It's a really great opportunity. You do need to get a home energy assessment first, because they need to make sure that you don't need any insulation. They don't want to be incentivizing people who aren't already as efficient as possible. So you would need to weatherize your home first, according to their recommendations, to qualify for that $10,000. If you want to keep your fossil fuel system running, you can still get an incentive for a heat pump installation. It's called a partial system incentive. And that does depend on the size of the system that you're putting in, the heat pump. And the incentive is based on how big it is. It's $1,250 per ton of heating capacity. A ton of heating capacity is 12,000 BTUs, I believe. And so most homes might need 3 to 5 tons of heating capacity. So your incentive might be $2,400, something like that, or 36. You might need an integrated control. That's a thermostat that speaks to both your fossil fuel system and your heat pump. So say it's fall and it's nice, fairly warm, and your heat pump is working just fine. But now, it's suddenly December and you need to have more heat from your fossil fuel system. The thermostat hits a point, say 32, and it says, okay, it's time to shut the heat pump off and turn the fossil fuel system on. So that's what we call an integrated control, and those are required in some installations. Just to touch briefly on the state rebates for the ground source heat pumps, that is $15,000 for a whole home ground source heat pump. It's higher because the installation of a ground source heat pump is going to be more expensive. They're going to dig up the ground in some fashion, either horizontally or vertically. And you're going to need to get large equipment on your property for that purpose. So that's why the incentive is larger. Ground source heat pumps are more efficient. So if you do have the space and the capital, you will have a lower operating cost if you do go that route. I just want to touch briefly on air to water heat pumps. There is an incentive for air to water heat pumps. Now, we talk about air source heat pumps, grabs the heat from the air, transmits it to the air in your house. But in an air to water system, it would grab the heat from the air and it would put that heat into a water tank. And then that water tank would be distributed throughout your house. Now you're suddenly thinking, oh, I've got a boiler. This is perfect. That's exactly what I need. I'm sorry. That is not going to be a one-for-one switch out, because the amount of heat that can be sucked out of the air and put into the water is not as much as can be generated by lighting a bunch of gasoline on fire and putting water over it. So a boiler boils water, and a heat pump can only warm water. And that warm water is not going to make your house as warm as your boiler does now. So we'll talk more about that in a moment. Also note, It's perfectly applicable for radiant flooring. If you already have radiant flooring or are putting in radiant flooring, that lower temperature can be perfectly comfortable for your house and adequate. There are very few experienced installers doing air to water, so it is a longer timeline as well, getting into the queue. Heat pump water heaters, just want to mention there is a rebate for heat pump water heaters as well. It is through the contractor. So you need to talk with your contractor about them getting the rebate for your heat pump water heater. These are great. They make your basement drier. And obviously it's another way to get off of fossil fuel if that's important to you, as certainly is to many of us. You do need to get that wired to a robust circuit. You can't just plug it in. There are plug-in models. You might have read about them. They're not popular in this area yet because the temperature that the water is coming in from the street is very cold in winter, and those plug-in models are just not sized appropriately for that. So on to the federal tax credit. $2,000 off your taxes when you install a heat pump. That's up to $2,000. It's 30% of your post-incentive cost. So say you put in a system that was $30,000 and you took $10,000 off of that as an incentive, you would be able to claim 30% of that $20,000 up to $2,000. And that's for heat pumps or heat pump water heaters. There are additional federal tax credits for things like electrical upgrades if you're installing heat pumps and heat pump water heaters. And there are smaller tax credits for others. You can't roll over the heat pump incentive from 1 year if you didn't use it all. It's 1 year, one and done. But there are there's 10 years in the Inflation Reduction Act, and you can install a new energy efficiency measure every year and take a new tax credit related to that new thing that you installed. There will be, you may have heard about the IRA rebates. There will be rebates, but we don't know when they're coming. It's rolling out state by state. It's a very stringent requirements for how that rollout is happening. And Massachusetts hasn't completed the process yet. When the rebates do come out, there are two types of them. One is for low and moderate income, up to 150% of area median income. I know in Boston, in the Metro Boston area, that 150% of AMI is about 200,000 for a 3-person household. I'm afraid I didn't look it up for Plymouth. So that is one, and then there's going to be one that's for all income levels that will be based on your projected energy savings of the whole project. So you'll need to work with a specialist to take advantage of that. But as I said, they're not. We don't know when they're going to come. And now let's move on to operating costs. Will you save money on your heating bills every winter? I cannot answer that question for you because it is completely depending on the efficiency of the equipment you buy, the temperature that it's operating out, how cold is the winter going to get, and what is the fuel cost that you paid last winter, and what will be the cost of electricity this coming winter. So those are all variables that I'm going to try to explicate a little bit more for you now. So first, let's talk about weather. Heat pumps are more efficient at moderate temperatures and less efficient at low temperatures. But 70 to 80% of the winter hours, if you count up all the hours of the winter that we need heat, 70 to 80% of that is going to be above freezing. And that's heat pumps are fine and happy and working quite well. They're gonna take more energy when it drops down below 32. We use a term to measure the efficiency of a heat pump that's called coefficient of performance. And that's what I was referring to before about you put in 1 unit of electricity and you get 4 units of heating power. That's a coefficient of performance of 4. So that's an important thing to think about as you're meeting with the contractors, but not so much, so much tonight. So I ran some numbers with the most recent utility numbers that I could get from Plymouth. I got $1.99 for a therm of natural gas and 31 cents for a kilowatt of electricity. And using those numbers and a measure of fairly efficient heat pump, I found that propane was going to cost you almost $3,000 in a winter. Oil was going to cost you $2,100, and I gotta move this a little more to read my thing. A heat pump was going to cost you $1,900, and a natural gas was going to cost you $1,500. So again, that is just a ballpark. And you really need to get a contractor to come in, and actually you want 3 contractors, sorry, it's going to be work, to give you bids and to tell you what equipment they think would work for your house for, completely replacing your fossil fuel or augmenting your fossil fuel as you want. And then sit down with your bills and figure out how much did I pay in the last winter for my heating fuel, and then try to project into the future for the lifespan of this next bit of heating equipment that I'm buying. What are those prices going to be? Now, the wonderful thing in Massachusetts is that you can get independent advice from heat pump experts through MassSave. And that's a fantastic service. You book it online, and you can get your 3 quotes from the contractors. You can share them with this independent consultant, and you can share your electricity bills and your gas bills or your oil bills or your propane bills, and they can look at all that and they can say, does not compute, does compute, I recommend or I don't recommend, or what are your needs. So it's a really, really great service, and that is for free. And if you, for some reason, don't qualify for MassSave, there are ways that you can pay for that same independent, high quality consultation. So let's talk about design considerations. When a home has ductwork, you have a furnace, not a boiler, and you have hot air ductwork that is, connected to your furnace and distributing heat throughout your house. That, because you already have the ductwork, it's a relatively easy replacement of that fossil fuel furnace in the basement with a heat pump air handler in the basement connected with a condenser outside. Now that, caveat, your ductwork, may not be adequate to the job, may have problems, et cetera. But that's a relatively easy, cost-effective one. Now, what if you have central air conditioning, but not a furnace? Central air conditioning ductwork might be usable, but it's a little bit more of a stretch. And you again need a technician to come in, take a look at that ductwork, and determine whether it could be used for heating as well as cooling. If you don't have ductwork, you have a boiler. And as I said, a boiler produces boiling water, very hot water, and that's distributed through your house, and all those radiators or baseboards are sized to keep your house warm when very hot water is fed into it. So you can't just drop a heat pump, even an air-to-water heat pump, into your boiler replacement and run it through the same system and feel the same degree of warmth. But you can go ductless, or you can even have mini ducted units where you're running very short duct runs through your basement or your attic, and not having to build whole new chases throughout the house. So you could have a single head that serves a large open area. You could have single zones, multi-zones. The mini ducted heads are great for serving adjacent rooms. Say you have 3 bedrooms on the 2nd floor. you may be able to just have one air handler in the attic that serves those three. Sizing a system is crucial. You do not want to oversize your heat pump. Obviously, you don't want to undersize because then you're not getting enough heat. But you think, oh, I want to be extra sure that I've got enough heat, so I'm going to oversize it. That's going to be a real problem in the summer because the cooling function happens faster than the dehumidification function. It's going to get cold, the heat pump's going to throttle down, and you're left with cold, clammy air. And it's potentially going to cycle on and off, on and off, on and off. And there's a lot of energy wasted in that on, off. So you don't want to do that. Yeah, I'm sorry, you don't have the slides in front of you. For the people who are in the room, we're looking at an illustration of a small apartment, a small house with 2 bedrooms and a great room that has your living room, dining room, and kitchen all open to each other. And you could potentially put, we're going to hypothesize that this home needs 24,000 BTUs per hour to maintain heat in the middle of the winter. You could put 124,000 head in your great room and know, oh, it's going to be like having a wood stove. You know, the bedrooms are going to be colder in winter, but they're going to be tolerable because we like it colder. And in summer, the bedrooms will be warmer. We're just going to put ceiling fans in, and that's going to keep us perfectly fine. That's one solution. What you don't want to do is put 9,000 BTU heads in each room. The smallest heads are 6,000. So a lot of times, people will say, oh, you got a small bedroom, we got to put 6,000 in there. If you have too many heads in too small a space, you're gonna put cold and clammy in the summer, and in the winter it's going to be cycling on, cycling off, cycling on, cycling off, because it's got too much capacity. It's going to get hot, and then it's going to throttle down, and you're going to lose efficiency, and it's going to be expensive to operate. So in this particular example, what I've called the perfect mix is a 12,000 BTU head in the common area and a 12,000 BTU head that is mini ducted to the 2 adjoining bedrooms. So that can be a solution as well. Next steps for your heat pump or research: schedule that independent consultation. I mean, you could schedule your contractors first and have them all come in, but you could do the consultation first, and that would help you develop your questions for the contractors. You can get that independent consultation from Mass Save. You can get it from municipal power companies in certain areas. You can also get independent consultations with a web-based company called EnergySage.com. My company has partnered with EnergySage for many years for solar referrals, and now they're doing heat pumps as well. It's basically like a cost comparison tool. They've pre-vetted contractors, and you get the quotes in an apples to apples comparison format, and you get the free consultation with their professionals who are independent and will be able to, point out nuances of the different quotes and learn about what your concerns are and help you see how the different quotes address your concerns. So that's really good. And I do recommend getting 3 quotes if you can stomach the time it takes to do that. Questions to ask heat pump installers: is your company one of the approved installers for the rebates that I'm looking for, the Mass Save or the municipal heat pump rebate programs? Will you formally calculate my heat load before I sign a contract for purchasing a specific piece of equipment? Now, a heat load is a measure of how much heat is needed. That 24,000 BTUs is what we posited as the heat load for that house. Somebody's going to hopefully come in and measure your house, cubic space that's in every room, windows, insulation levels, et cetera, and run that through a technical spreadsheet and come up with a number that's your heat load calculation, 16,740, whatever it is, BTUs per hour that you're going to need. A lot of companies will just estimate that, and you can go with that, but you want to ask them, will you do a manual J heat load calculation? Will you formally calculate my heat load calculation before you spec the equipment? Because you want to know that they're not oversizing, and obviously not undersizing. And is the equipment that you're recommending eligible for the rebates? So they may be Mass Safe certified, they may be calculating your heat load, but if they're saying, oh yeah, we got a deal on these heat pumps that are actually made for Georgia, so we're trying to pawn them off on people, you want to make sure that the equipment will qualify for the rebates that you're seeking. And that Mass Safe consultation comes, you can ask them to do a quote comparison where they actually do the side by side. And just clicking through to my final slide. I give these webinars through our company frequently, so you can go to greenenergyconsumers.org to find out when the next webinar is going to be. I believe it's going to be Tuesday, August 20th, and you can find recordings of previous webinars on our YouTube channel. If you just search Mass Energy, which is the name that we did business under for many, many years before we became Green Energy, you'll find us.